Out there in the cold, silent darkness of space, something truly amazing has been happening. A giant eye made of gold and mirrors has opened. It is looking out into the universe, farther than we have ever looked before. This eye is the James Webb Space Telescope. It is our greatest tool for discovery. It was sent into the cosmos to answer some of our oldest questions. Are we alone? Are there other worlds like ours? The telescope floats far from Earth, away from the bright lights of our home. It is in a special place where it can see clearly. Its mission is to see the first stars and galaxies, and to look at planets around other suns. We have waited a very long time for this moment. So, what is this place, this Proxima Centauri b, and why is it so important to us? To understand, we must first look at our own cosmic neighborhood. Our Sun is just one star among billions in our galaxy, the Milky Way. The star closest to our Sun is a small dim star called Proxima Centauri. It is so close that if the universe were a big city, Proxima Centauri would be our next-door neighbor. It is about 4 light-years away. That sounds very far, and it is. But in the vastness of space, it is just a short walk. In 2016, scientists made a stunning discovery. They found a planet orbiting this close star. They named it Proxima Centauri b, or just Proxima b for short. This was exciting news. Not only was it the closest planet outside our solar system, but it was also in a special place called the Habitable Zone. To answer this question, we needed a very special tool. We needed a telescope more powerful than any we had ever built. It is not like the telescopes you might see on Earth, or even like the famous Hubble Space Telescope. The James Webb is different. It is designed to see a special kind of light called infrared light. This light is invisible to our eyes, but it holds many secrets of the universe. Infrared light can travel through clouds of cosmic dust that block normal light. This allows the Webb telescope to see things that Hubble never could. It can peer into the hearts of distant galaxies and see stars being born. The most important part of the James Webb Telescope is its giant mirror. The mirror is what collects the light from faraway objects. The bigger the mirror, the more light it can collect, and the fainter the objects it can see. The Webb's mirror is huge. It is over 21 feet wide, made of 18 golden hexagons. It is so big that it can collect much more light than Hubble. Another amazing thing about the Webb telescope is where it is located. It does not orbit the Earth like Hubble does. The day finally came. The James Webb Space Telescope was ready. Its instruments were cooled, its mirrors were aligned, and its mission was clear. It was time to turn its golden eye toward Proxima Centauri. The plan was simple, but the task was incredibly difficult. The telescope would stare at the star system for many hours. It would wait for the exact moment when Proxima b passed in front of its star. This event is called a transit. During a transit, the planet blocks a tiny amount of the star's light. By measuring this dip in light, scientists can learn about the planet. The tension was high. All around the world, scientists waited. They had spent years preparing for this. They had run countless simulations. Now the moment of truth was here. The telescope began its long observation. While we all hoped for the best, there was a deep-seated fear among the scientific community. It was a fear born from our understanding of red dwarf stars like Proxima Centauri. These stars are actually the most common type of star in our galaxy. They're small, they're cool, and they live for a very long time. But these stars have a violent temper. They're known for their powerful stellar flares. Sudden, massive explosions of energy and radiation that erupt from the star's surface. For a planet like Proxima b, which orbits its star so closely, these flares would be a constant threat. Imagine living on a world where, without warning, the sky is filled with a blast of X-rays and charged particles. This radiation would be deadly for any life on the surface. It would be like standing next to a giant cosmic microwave oven. Any living thing would be cooked. This was the primary fear, that Proxima b, despite being in the habitable zone, was actually a radiation-blasted wasteland. A world that was constantly sterilized by its own parent star. It was a frightening thought. These were the fears that haunted the dreams of astronomers. Then the moment arrived. The teams of scientists finished their analysis. The James Webb Space Telescope's first detailed look at Proxima Centauri b was ready to be shared with the world. The image itself was not a picture like you would take with a camera. Instead, it was a graph, a chart of data. But this data painted a picture more powerful than any photograph. It was a picture of the planet's reality. And as the results came in, a quiet hush fell over the scientific community. The image and the data behind it confirmed our deepest fears. The first and most important finding was about the planet's atmosphere, or rather, the lack of one. The Webb telescope looked for the telltale signs of gases as the planet passed in front of its star. It found nothing. There was no sign of any significant atmosphere at all. This was the brutal truth. Proxima b is a naked world. It is a barren rock, stripped of its gaseous blanket. The relentless flares from its parent star have done their work. The news about Proxima b was disappointing, to be sure. It felt like a setback in our grand search for life beyond Earth. For years we had pointed to Proxima b as our best hope, our closest chance. Red dwarf stars are the most common stars in the galaxy. If their planets are all being sterilized by flares, then the number of truly habitable worlds out there might be much smaller than we thought. This suggests that planets like Earth, orbiting stable, sun-like stars, might be more rare and more precious than we ever imagined. But this discovery is not the end of the story. In fact, it is an incredibly important piece of the puzzle. Science is not about finding what we want to find. It is about finding what is real. The James Webb Telescope has given us a crucial piece of evidence. This knowledge is powerful. It will help us refine our search. Now, when we look at other planets around other red dwarf stars, we will know what to look for. There are countless other worlds for it to explore. There are planets orbiting stars like our own sun. There are giant planets and small, rocky worlds. Each one holds a new mystery, a new possibility. The story of Proxima b is not one of failure, but one of learning. In the end, the story of Proxima b and the James Webb Space Telescope is a story about us. It is about our unending curiosity. It is about our desire to reach out into the great unknown and find our place in it all. We looked at our closest cosmic neighbor with our most powerful eye, and we found a harsh and empty world. This might seem sad, but it is also beautiful. It is beautiful because it is the truth. And the pursuit of truth is what drives us forward. The journey of discovery is never a straight line. It is filled with twists and turns. The James Webb Telescope will continue to write new chapters for us. It will show us worlds we have never dreamed of. The search is far from over. It has only just begun. This is a journey for all of humanity. When we look up at the night sky, we are all looking at the same stars. So let us look up at the stars tonight. Not with sadness for a lost hope, but with excitement for the mysteries that still await. The universe is whispering its secrets, and for the first time we have an ear sharp enough to listen. If you believe in the power of discovery and want to follow along on this incredible adventure, join our community. Like this video and subscribe to Cosmic Discover for more stories from the frontiers of space.